Okay, so the next video, the third video, is on page 382, and we're going to cover how to go volume to volume. Okay, so here we're going to bring stoichiometry, and this is how this chapter really differs from chapter 18, is now we're going to bring equations or reactions back into it. So I want to combust methane, okay, and when you combust, you're reacting with oxygen, okay? And when you combust, you always get the same two products out, carbon dioxide and water, okay? So both of these are gases, water gas, carbon dioxide gas, oxygen gas, methane gas. That's why there are the G's. We have to balance. There's one carbon on the left side, there's one carbon on the right side. But I've got 4 hydrogens here and only 2 there. So I'm going to have to put a 2 there to balance it out. Now I've got 2 oxygens here and 2 oxygens there, because the red 2 multiplies my oxygen, so now I've got 4 oxygens. So I'm going to have to put a 2 there, and now everything is balanced. Okay? So I've got 15 liters of methane gas, and I want to figure out how many liters of hydrogen gas, or of water vapor will be produced, H2O. So whenever we do these problems, when we did them in the past, the first step you'd always did was get to moles, use mole ratio, then convert to what you're trying to find. If you don't believe me, go back and look at chapters chapter 6, and you'll see that we did that over and over and over again. So start with our known, 15 liters. We want to get it to moles, okay? So how do we get liters to moles? Well, the way we do it is either using PV equals nRT, or in this case, since we're at STP, I can use the conversion that 22.4 liters is equal to 1 mole. Okay? So we're going to keep it simple. We're always going to do it at STP, so that we're always going to use this nice conversion here to get it to moles. So the first step, use that, get it to moles. The second step is to use the mole ratio to get it to what we're trying to find. Well, what is the relationship between methane and water? It's a 1 to 2 ratio. So for every 1 mole of methane, I'm going to produce 2 moles of water vapor. And then my last step is I want to convert it back to what I'm trying to find. In this case, I'm trying to find liters. So what is the relationship between moles and liters? Well, if I'm at STP, 1 mole is equal to 22.4 liters. So I can multiply this out, and my answer is 7.5 liters of water gas. Okay? So something to notice here is that here we're dividing by 22.4 liters. Over here, we're multiplying by 22.4 liters. So what ends up happening is really these 2 steps cancel each other out. And so the problem really just simplifies to 15 liters of methane gas, and then going straight to the mole ratio. For every 1 mole of methane, 2 moles of water vapor. Oh boy, I did math wrong. Sorry, I'll take an error. I just realized that. again, once this is embarrassing, 15 times 2 is 30. You're all probably trying to figure out how I came up with 7.5. The answer is 30. So, but anyhow, the answer is the same. Okay, so if you use this here, you're just going to undo it over here. So if the temperature and pressure do not change in the problem, all you have to do is use the mole ratio. Okay, so let's do one other example here. Okay, because they're going to do this in the book. I did it at STP just to prove it to you. Okay, but suppose we had a problem like this. Let's do, nitrogen gas reacting with hydrogen gas to produce ammonia. To balance it, we're going to need a 2 here and a 3 there. Okay? And I want to know how many liters of hydrogen do I need in order to react with 14 liters of nitrogen. Okay? I want to know how much hydrogen do I need in order to react with 14 liters. So the key is they'll tell you that the temperature and pressure are constant. If the temperature and pressure do not change through the problem, then you can just use the mole ratio. So the ratio is for every 1 mole of nitrogen, I will produce 3 moles of hydrogen. So that means I'm going to need 42 liters of hydrogen gas in order to make ammonia. And by the way, ammonia is what you need in order to make fertilizer. Okay, and this is what bacteria do. They use nitrogen and hydrogen to make ammonia. Okay, so as long as the temperature and pressure and change, you just go to that. So you don't have to be at STP. And that's it.